Hi, so for my problem where it is how long does it take light to travel through a piece of 3 mm thick piece of window glass? So basically what we were looking for is the time because it's asking it how long does it take. So first let us write our knowns. So we're looking for time and we know the thickness of glass is 3 mm, so that D equals 3.0 millimeters. And we can also convert that to meters because that's what we usually work with, units in meters. So that'd be 3 times 10 to the negative 3 meters. And we also know the index of refraction of glass, and that is n equals 1.50. And the index of refraction of glass, or index of refraction, is basically like the number of times slower it is compared to a vacuum space, if that makes sense. So now we need to find, or we need an equation that would give us time. So we learned distance equals rate times time, which is basically distance equals the velocity of glass times time, because rate is basically how fast something is going, and so that's basically the velocity of something. And so using algebra, we isolate t, giving us t equals d over v glass, and that's just simple division, moving the v glass over to the d side. And so basically we need to find t, we're given d, but now we need to find the velocity of glass, but that's not given. So we use another equation, which is n material equals c over velocity material. And so we can isolate v by algebra again, and that would be v equals c over n. And n is just the speed of, or c is just the speed of light. And so basically we use this, plug that in over there. And so our new equation is t equals d over c divided by n, which if you just move the, you just basically move the n over, up on top. So t equals d over n glass over c. And so basically now we have everything we need to find t, because we have the distance, we have the refraction, and we have the speed of light, which is c. So now let's just plug in the numbers, which would be 3.0 times 10 to the negative 3 meters, that's our distance up there, times the refraction of glass, 1.50, divided by the speed of light, 3 times 10 to the 8 meters per second. Plug that into your calculator, and we get 1.5 times 10 to the negative 11 seconds, which is pretty fast because it's the speed of light. All right, moving on to part B. Through what thickness of water could light travel in the same amount of time? So what are we looking for this time? Through what thickness of water? So we are looking at for the thickness, which is distance, question mark. And also it wants the same amount of time as the question before. So time, which we just got from here, would be 1.5 times 10 to the negative 11. And the index of refraction of water based on the chart we're given is n equals 1.33 for water. Okay? So we do the same thing. We need to find distance, and an equation that we're given to find distance is distance equals rate times time, which we convert rate to basically velocity of water. So distance equals the velocity of water times time. And so now we have the same problem where we don't know the velocity of water, and so we use the equation like basically up from before to convert v to c over n. So that way we get c over n water times time. Yeah? Which is basically c times t over n water. So now we have everything we need. Okay, so now we have everything we need. We have the speed of light, we have the time, and we have the index of refraction of water. So we just plug everything in, which gives, let me rewrite this real quick. N water, and so equals 3.0 times 10 to the 8 for speed of light, meters per second, times 1.50 times 10 to the negative 11, which is our time, over the index of refraction of water, 1.33, which gives us 3.4 millimeters thick. And that is how fast, or what thickness would be the same amount of time. Yeah.